I went ahead and took the liberty of factoring both the numerator and the denominator because, and this might start coming back to you. I mean, we did exactly this when we were analyzing rational functions way back when, but now we get to analyze them using calculus as well. So points of discontinuity, we have x equals 5. So x cannot equal 5 and x cannot equal negative 3. So those are the points where x equal are the discontinuities. Discontinuities, I'm going to abbreviate. So are the discontinuities. We have discontinuities at x equal 5 and x equal negative 3. But what kind are they? Well, as you can look up here where I factored, you can see that when I factored the x equal when I found the x equal negative 3 as a discontinuity, I see that it came from the factor of x plus 3, which I could cancel. And once I cancel that, I realized, well, that's a removable discontinuity. Okay, so I can just put the word removable right underneath the x equal negative 3, and then underneath the x equal 5, which didn't get canceled, that would be an infinite discontinuity. So with rational functions, we either have infinite or removable discontinuities. We'll get the jump discontinuities when we analyze piecewise functions, which we'll do at some point. Okay, and did I do that? Okay, so part A, points of discontinuity and each type. So that takes care of, and if this were a test question, you'd get 1 point for each discontinuity and 1 point for describing the discontinuity, listing it as either infinite, removable, jump, or oscillating. It's going to be a rare occasion that you're going to get an oscillating one, so just focus on the infinite, removable, and jump.